Okay, this is going to be a demo in Rhino and Grasshopper to help you guys build these models of your kebab towers. I'm going to go over a couple techniques that hopefully will make your life a little bit easier. I covered some of this before, but based on what I'm seeing in class, you guys seem to have a few questions about some of the more basic stuff. So this video might go a little bit longer. I'll put some timestamps in the description below. Okay. First off, regarding Rhino in general, since this is, for many of you, most of you, the third semester that we've worked on this tool, I recommend, if you're still feeling kind of miffed about some of the basics, that you invest some time to look at some of the learning resources available to you. I made a bunch of videos last year you can look at on our media space page. Or also there's lots of other resources on the internet. LinkedIn Learning, I've mentioned before. UIC LinkedIn Learning, if you look at that, has a great video called Rhino Essentials. But you can also go to Rhino's own website under the Learn tab here. And there's lots of videos here. The first couple videos here, you see they're very short, a couple minutes, and they cover a lot of the basics. You should invest the time to watch these, I think. Also, if you have specific questions about how to use this stuff, like come to office hours or email me or your TAs. You should not be moving through school kind of expecting that you know how to do this stuff. You should, in fact, move through school not knowing things and trying to learn as we go. Okay, so Grasshopper, kind of cover some of the basics of what it is. If Grasshopper is not open, you can, in Rhino, just type Grasshopper, and it will open up this little window. The window kind of floats above. What I like to do is kind of have Grasshopper off to one side and then kind of minimize my Rhino window so it's off to the other side. What Grasshopper is a kind of visual programming environment. So it codes for you, but rather than having to write code, you do it with these components or these little nodes that you connect with wires. And the parametric part of it means that there's parameters or numbers that change. And then the numbers, as they change, will influence kind of the data that flows through these wires and will change the geometry that kind of comes out on the other side. Okay, so I'm going to start from a little bit of basics here and talk about a few things I noticed yesterday. One, when you're working in Rhino, a couple of things that are going to trip you up quite a bit is like the difference between, say, a line, which is like two points here, or a polyline, which can be multiple lines joined together into what we call a polyline. Okay, same thing for a surface. If I was to say I have a plane and I had a plane here, this is just one surface. If I look at my properties menu, and if you don't see properties, you can type properties. It tells me it's a surface. If I was to copy this surface, and what I see a lot of you doing, say there's two surfaces here, and I type group. These are now, if I click on one, the two individual surfaces, and if I look at the properties, it tells me here, there's two surfaces that are grouped. So it may seem like they're joined together, but grouping is just a way of kind of collecting things so that they're easily clickable. It doesn't actually physically like weld them together. So I'm going to type ungroup. And I'm going to move this and connect it to this one. So I have two surfaces, and then if I hold, say, Shift and select both surfaces and type join, it will join those two. And now if I click, it says open polysurface. So I have a polysurface here. Same thing with lines. So I could have like a second line that's connected to this one. And again, it's only going to snap if on my left side here, the O snaps are turned on. and you can investigate these, but you're going to want to have your O-snaps on so things snap. So I've got one line, I've got two lines. If I hold shift and select both of the curves, both of the lines, and I type join, it will now be joined into, it just says open curve, but this is a polyline. Similarly, if I have a polyline here and I type explode, it will explode it into 5 individual curves. Okay, so this is important for lots of reasons, but particularly for this little Grasshopper definition that I have. You just really want to know that what it means when I say join a line together. If you move this across, so these lines cross each other but they don't touch at the point, and I try to join, it will say unable to join curves. It won't work. Okay, so many of you for the massing models are experiencing some issues with your booleans. Booleans not working. Usually it's because you don't have like a closed polysurface, or things aren't nicely joined together. Okay. The one thing I'll say about those massing models is they don't need to be perfect. They are kind of like sketch models in their own way. They are to serve as a tool to help you think about the form and the massing of your overall shape. But then when you get to this level of detail into it, it will change. The overall form that you figured out in the massing model is just taken from an extrusion of a tracing of a photograph, right? At this point, you should be kind of maybe minimizing or simplifying things so they become a little bit more clear and kind of relate more back to the DNA of the models that you made for the midterm, the models in the first half. Okay. That's all to say, don't spend any more time on the massing models at this point. If you have to get the Boolean split to work, just use split command, and that'll work good. Okay. All right, so before I get into all the stuff that I have in the template file, let's just cover some of the basics again. Okay. So anything that I can do in Rhino, any command that I might do, like if I want to do a sphere in Rhino, I can also have a sphere in Grasshopper. And I should do this near the origin so you can kind of see it. Right? The thing is, in Rhino, if I want to make another sphere that is, let's say, smaller, of a different size, so I type sphere, I type the center of sphere, and then I can type a radius. I can do like 5 feet instead, so it's a little bit smaller. I kind of need to rerun the command each time, or I can do a transform on it, like scale. So this will get it bigger or smaller, right? So we can kind of think of things in Rhino as being kind of one-offs, kind of static in a sense. While this sphere component in Grasshopper, and I'm going to turn on a plugin called Bifocal so you can see what's going on. The sphere component has some inputs, and we can, at the top here, change the display to full name so we can see what the inputs are. And you can see it's asking us for like a base plane. So I can have like, say, a point that's over here. I can reference that point into Rhino into Grasshopper by double clicking and typing geometry, kind of a catch-all little container for geometry. If I right click on it, I can set one geometry, so that will set this point that I have in Rhino into my Grasshopper definition. I can like plug that into here. And then I can have a slider for the radius. And so this is where the parameter part comes in. Lots of ways to make sliders under the input tab here. There's lots of different inputs. Number slider you can see right here at the top. But I can double click into the Grasshopper and say 0 is less than, I don't know, 5.00. Enter. So this gives me a number slider. And the other thing that you use quite a bit is a panel. This allows me to see the data, the information that comes out of anything, any of these components. In this case, it's just going straight in. But I can put this here to the radius. And now this sphere, if I change the slider, will get bigger or smaller. Okay. And this can be linked in multiple ways. So this kind of functions like a little synthesizer. So we can do things like, say, scale. Or let's say I want to move it. That's a popular one. I want to move it. So I want to move this. And it asks for, this is where there's a little bit different language. Because obviously, if we're dealing with something that can change dynamically, we have to think about things like orientation or direction. So in this case, like a vector. So in which way are we moving it? Or in this case, for the sphere, it's asking for this base plane. So this concept of planes and the concept of vectors are kind of important. And again, there's lots of resources for you to look at to go into more detail. Internet's full of, or YouTube's full of stuff. I won't be able to give you a full tutorial on every single detail of Grasshopper in the course of this tutorial. But that's just all to say, like, you should get to know what vectors and what planes are. Planes refer mostly, and we can see in Rhino here, just a little smaller. Down here at the bottom left, you'll see these little widget that shows the X, Y, and Z sort of axes of the Cartesian world space. And so there's different world spaces. Generally, the one that we are familiar with is the Cartesian one, X, Y, and Z. And so a plane, and if we zoom out, you see that there's this grid here, right? Like kind of that base grid in Rhino that we're used to looking at. That is an XY plane, okay? And I have a point here and by default, it's on the XY plane. We can set points to be, say, in the XZ plane or the YZ plane or any of the infinite other planes that we can create through rotation. Okay. Motion, let's say I want to move it. We want to go in a direction, so a vector. There's lots of ways we can create vectors, but typically when you're beginning, we like to use the X, Y, and Z. So if I want to move it up, I want to have it move in the Z direction by a certain distance. And so again, I can make another slider. Let's say 1 is less than 5. And because I didn't do a decimal, it'll just move in single distance integers here. And it will move up, okay? And then whatever you have, like a piece of geometry, you can tell it's kind of ghosted, this sort of red thing. And it's still parameterized, meaning I change these numbers and it will get bigger or smaller. I can double click into the slider and type 5 and it will get that bigger. You'll notice there's a couple of them now. You've got like the original point, we've got a sphere, and then we've got the sphere after it got moved. So often we're inside of Grasshopper trying to hide the preview of certain things. And so you can do it up here. But usually what you do is click on your middle mouse button and it brings up this little window. There's a lot of these are useful. We usually use the disable and enable preview, or down below, enable or disable. And so when you open up this template, you'll notice I have pretty much everything disabled. And that's because there's a lot of information or a lot of components on this one document. So when you're working with a specific component or cluster of components, you can select them and then enable them. But in this case, I just want to disable the preview so I can see just this one. And we can even do a geometry node that we connect the end to. Same deal, I can turn this off. Okay, so say at this point I want to go back into Rhino. So this has been fluid and flexible. One might say kind of like a batter, a little soupy. So what I can do is bake it. So if I right click on the component and choose bake, it takes it out of the soupy flexible mode and ossifies it onto some layer. It moves it from Grasshopper back into Rhino. So now I can click on this thing. It tells me it's a closed surface and it's a piece of geometry that I have in Rhino. Okay. So sometimes we make geometry straight up in Grasshopper and then bake it into Rhino. Other times we kind of start with maybe some geometry in Rhino, link that into Grasshopper, alter it, create more geometry, and then go back into Rhino. Okay. And I'm actually gonna pull this off to the side. I want to copy these in one by one. Computer's going a bit slow with the processing. Okay, so the first kind of reading from top to bottom like a book. These first definitions here. I'm going to select them. I'm going to click my middle mouse button, and I'm going to enable them, turn them on. So these are two commands that are good for converting lines into 3D shapes. Something that we could then maybe cut a section through, maybe a laser cut. Or something that when we look at in our section perspective isn't just a line, but has thickness to it. Okay, so lofting, we talked about this in Rhino. Lofting is when you have, say, a line and, say, a curve. And if I type loft, it will connect. This one's needs to be aligned, but it will connect these into a surface, right? So I could loft curves together in Rhino. In Grasshopper, you can loft surfaces together, but generally we're going to do the same thing. So lofting, we're going to use, like I say here, best for straight lines. Sweeping is going to be good for polylines or curves. So let's say I have like a rectangle in Rhino. Let's stick it here. Actually, let's stick it on the curvy guy. So if I was to do the sweep command, and I want to sweep along this rail, this shape, without adjusting at all, it's going to do it, but it's going to keep it flat. That's because I didn't orient my curve to the sweep at all. So I could kind of like rotate it some way, like maybe it's like this and like this or something. It's a little bit closer. And now if I did the sweep command, select the rail, select the cross-section curve, it will look a little bit better. It's still kind of funky. It's because the sweep command really likes to have whatever shape it is that you're sweeping along the rail curve to be perpendicular to the edge of that. The little definition I've created here sort of simplifies that process a little bit for you. And I've left some notes, at least on the first one here. I won't talk about those too much. Okay, so lofting, best for straight lines. So let's do it on just a straight line here. So I'll take one straight line. Let's right click and set one geometry. And we'll kind of work, I'll work through these components by turning them, the preview on so you can see. Okay, so perpendicular frames, what this does is it makes frames or planes at certain points along the line. By just having in the count here, one segment, so there's one segment with the kind of frames at the beginning and end of it. That's all we get. If I did a slider like 1 to 5, and I made this slider like a 3 and put this into here, we're gonna get 3 different segments, okay? I'm just using this to get these planes at the ends. And this will, if I was to move this line so it goes up, these planes you can see readjust. They're always going to be perpendicular to the curve in whichever direction, okay? This guy makes a rectangle, and it's making it at the origin. We have this little rectangle here. And if I can make this size, I don't know, 3 feet by 1 foot. If I click on it, it'll show me a little preview. There's actually like a plane going on there too. That's the grid we can see. And so consider this like the thickness of whatever the column or beam is that you're working on. This little component gets the area, which gives me 2 outputs. I get the area, so like a number, how, you know, length times width, and I get the centroid. So that's like a point in the middle of the rectangle right there. Okay. What I'm using that point for is for this component called orient. And if you ever want to know like where these components come from, you can hold Control Alt and click, and it will pull up where in the menus it might live. So orient, you can see, is in this menu for, this is transformation. So things like mirroring, moving, orienting, rotating, all these things. Orient is not a command that we use in Rhino straight up, but we use in Grasshopper quite a bit. Okay, basically it's going to allow me to take a source geometry, in this case that rectangle, and it's going to kind of move it from some plane to another plane. So I'm moving it from the centroid, which is the center point here, in the XY plane, to a target being my, I turn these on, previews, we can see the target is these perpendicular frames. And again, if I don't, unclear kind of what I'm looking at, I can type panel and I can plug this in, and this will tell me there's 2 planes. There's a lot of numbers here, but there's 1, 2, 3 numbers in the origin, and then the Z direction, which basically tells us the normal direction of this plane here. Okay, so it's moving that rectangle to the ends of my line. 1 rectangle, 2 rectangles for this straight line. Okay, and then all I'm doing is, lost it here. I'm lofting. So lofting takes a bunch of curves and draws a ruled surface in between them. And then I'm capping, and so that makes a cap on the edge of it. And the rest of this we'll talk about in a second. That's kind of the end. So that is turning a single line into a capped, kind of extruded polysurface. Say I was to copy this line a bunch of times. Let's say I was to do another line that was maybe going across like this. Like here's a bunch of lines. So let's select these. Let's go back to the beginning of my definition and the input lines here. I'm going to right click, and rather than 1 geometry, I'm going to say set multiple geometries. So that will select multiple geometries. And again, if I want to change the geometry or the proportions of the cross sections, I can change it here. Say you want even thicker numbers or smaller numbers than what I have. I think the max I have is 3. We can always double click on the number slider. It'll pull this up, and I can change some stuff like, is it a integer? Is it a floating point number with decimal points? Here's the min and max. Maybe I want the max to be 9. These things are gonna get really chunky, really big. right? So you can kind of see there's like a bit of an orientation, a bit of a grain into which way it does this. But generally, I think you guys should be working like sort of flat. This is maybe not the best example. It's not flat, but I guess I could change that. Sort of rotate just in Rhino. Okay, so there's that thing laid out, and you can see the way that overlaps. These are still, if I go to the end of this, and if I'm going to delete these, and I plug in a panel, it'll tell me that there's like a bunch of closed B-reps. B-rep means boundary representation object. Basically, it's Grasshopper lingo for a surface or polysurface. This little component I have here is a solid union, otherwise known as a Boolean union. So I can type solid union. All of these are underneath the intersect tab, and there's a bunch here: boundary volume, solid difference, solid union, solid. These are like your Booleans, okay? So solid union, these all need to be closed for this to work, thus the cap. And I plug this into a solid union, and the output will be one closed B-rep, which is one object that goes through there. Okay? So again, lofting works best for straight lines. Say, let's take this polyline that I have here. Let's join them, make sure they're all together. Let's plug this one, set one geometry for the loft, and you can see what it does is it just takes the frames at the beginning and end and lofts that square between them. So it's not taking into account the lines at all. For that, you are going to want to do the sweep. Okay, so I have a similar setup here. Here's our member cross section. Here is our perpendicular frames. Here is the orient command. And then rather than lofting, we have sweeping. Okay, so let's plug the polyline into the sweep. So set one geometry. In Grasshopper, you can always do Control A to select everything. Click your middle mouse button, click your disable preview, and then I could just turn on my sweep, and we'll see how it looks. Okay, so this isn't like the best way to do this. It's my quick, easy way. You can see the corners are a little bit off here. It's something that I think at the end, when you're gonna either do the drawing or make the cutouts for the laser cutter or something, you can kind of fix that a little bit. There's ways to deal with it, but it complicates the process quite a bit. So we're just gonna kind of leave these little bits and corners like as they are. We're not gonna worry about it too much. Okay, so same thing where we have a sweep fed into a cap. The cap, where's my panel? Plug this in. It'll be this 1, 2, 3, 4, 5 different B-reps. And so if I was to plug this into the solid union and look at it, now we're down to one closed B-rep. This thing I have over here, this is a custom preview node. If I deselect everything and turn this on, it just kind of previews based upon this color. So if I double click this, I can change the color, make it blue, make it pink, whatever. But remember, this is still geometry that only is in Grasshopper. I would need to, we can do the preview, or we can do the solid union, right click and bake it, and that will bake it back into Rhino proper. And there I have a piece of geometry. Okay. What I'm showing here with this is basically, let's imagine this is some kind of truss. So let's do a polyline. zigzagging back and forth. All right, so I want my straight lines, or I want the polyline to be the sweep, and I want the straight lines to be the lofts. So set multiple geometries. Okay, let's turn everything off. What I have here, this is a merge component. Type in merge, this thing comes up, there's a couple of them, but merge is the one you want. This takes multiple data streams. Delete it, type merge. So I can take the capped lofts, which in this case is 5 individual closed B reps, and the capped sweep, which is yeah, we can leave the solid union to the end. 4 individual B reps, 1, 2, 3, 4. These are getting merged together, and these can get fed into the solid union. And what that will do, if I plug this out, we have 1 closed B rep. So if I hide everything, turn on the preview, 1 piece of geometry, 1 solid polysurface that combines all of these lines. And this is all parametric, right? So I can, let's say I move this point, move it down here, it will update. Okay, so I can right click, bake, take this, and now I have a piece of geometry inside of Rhino. Okay, so I hope you guys are seeing, like, even just with this component, how powerful this can start to be. Just working with like tracing lines, or maybe just drafting lines inside of Rhino. I'm working in the 3D view. You guys should probably be working on a combination of top and front and right views as you go. Okay. I'm going to move on to the next section. I'm just going to copy and paste this stuff into here. Let's turn these on. Okay, so this next section, these use a series of components. It's going to come up blank if you don't have a plugin called Lunchbox installed. Lunchbox kind of moving around the internet a little bit. This is one of the most commonly used plugins for Grasshopper. And so by plugin, I mean it's a piece of code that someone developed that augments the base capabilities of Grasshopper. This is why I'm teaching you guys Grasshopper. This is why it's so powerful in the industry, because it's extensible. It can be used for lots of different things. Most plugins are downloaded from here, Food for Rhino. So the ones that I use are Lunchbox, and there's also Pufferfish. There's a couple others maybe. Pufferfish is a great one. It has this offset surface component that's really great. You are going to have to like log in or register here. You can't just download it without registering. But once you do, down here, you just want to download whatever the latest one is. So check the date and download the latest one. When you download it, it will, let's see if I have any. It's like one here. It's like a GH file. It might come zipped. Generally speaking, right click on whatever you download, go to your properties, and there might be a little checkbox here called unblock. If there is, click on block and hit apply. And then what you'll be able to do in Grasshopper, you go to your file, special folders, components, and this opens up your Grasshopper library. When you first do this, yours will be empty. You won't have any extra ones. I have a bunch of them here. Okay, and then what you can do is, like in our downloads, I have this Mesh Tools one. I can just drag and drop or copy and paste straight into my Grasshopper components otherwise called the libraries folder. Okay, and then once I close Rhino and restart Rhino, that particular plugin will be installed. For Lunchbox, you could do it the same way off of Food for Rhino. Also, I think they have a new way to do it, which is a little bit better. If you type in PackageManager into Rhino, it will open up your Package Manager, which is a way that you can load in different plugins. And if you just search for Lunchbox, it will pop up here, and then you can click install. It's that easy, and you can do it. And I tested it this morning. This works on UIUC Anywhere. You should be able to open the Package Manager and install Lunchbox on UIUC Anywhere. And you should also be able to open up your special folders, components folder, and then load in any GHA or DLLs that you download off of Food for Rhino. So for the Pufferfish and any other ones that I might talk about. The trick being, I'm not sure if when you reopen UIUC Anywhere, whether it will stay loaded. Like you might need to reload those every single time. So you can maybe download them to your OneDrive, and it's only a couple clicks to get it loaded. Okay. So let's move over to Lunchbox. Lunchbox here is the plugin. You can tell I have lots of different plugins that I've been downloading and playing with over the years. Lunchbox has lots of pre-made surfaces, mathematically based surfaces, Mobius strips, toruses, different platonic solids. It's got ways to work with JSONs and CSVs. This is basically how we can communicate with like websites or communicate with CSVs or Excel files. Super, super powerful tool, but yeah, beyond what we're doing. We're going to be playing with panels and structure. So the first ones I have are structure, and you may be kind of interested by this. So there's a bunch: braced diagrids, grid structure, and then got space trusses. We'll kind of avoid these a little bit. So the way these work, and maybe let's go into like the side view. Let's draw ourselves based on our site, like a little rectangle. I'm not measuring right now. Just a rectangle that's on the side of our site. I'm going to input that as the input surface. I'm going to move it a little bit. And what's this first one here that I have? Braced diagrid. Okay, so it has inputs. It's got U and V. So how many divisions in the U and V? If you ever see U and V, you can basically think about it like X and Y. But it doesn't refer to the Cartesian coordinates, so the kind of world space of X, Y, and Z, which would affect any piece of geometry that I have in the scene. It's referring instead to kind of the space of the surface. And so on this rectangle, there's like left side, or left and right, and there's a top and bottom. Left to right we'll call U, top to bottom we'll call V. Okay, and this is nomenclature you'll see a bunch. It just refers to some divisions along a surface. Okay, and we can see as I change these sliders, it will change the divisions of this surface. Okay, so you can see where I'm going here. The outputs, if I look at this, some of the outputs, for some of them are just one node of lines, or one output of lines. Some of these have two, in which case one of them is like the verticals and one of them is the diagonals. So this is useful, if you're actually designing trusses where your diagonals might be like a little bit smaller. I've copied the other ones down here. Let's play with the Loft. And in fact, I can just plug in both. The Loft, if I hold Shift, it will add two pieces of geometry into there. It's going through, it's capping it, and then I don't need the merge because I'm not doing the sweep here. So I'm just going to bypass it and go straight to the solid union. Let's turn this on. And there you have a single closed B-rep. Right? And this is adjustable. Make these a little thicker. They're getting a little bit weird on the side there. And so we can kind of tell I've got these lines, like the one at the top is rotating it in a funny way. Same with the one at the bottom. And so this is where, like, there's ways in Rhino or in Grasshopper that we can be a little bit smarter about how we handle this stuff. But I would say sometimes, like, in between different components, I've got all this stuff. I'm just gonna move it over a little bit so we can kind of see, like, in between these components, rather than having this wire that goes through, what I could do is break it up into easier elements. Okay, so in Rhino, I'll make a new layer live. I'm gonna right click and I'm going to bake, and right click and bake. So I've got lots of lines in there. And then I'm going to, on the inputs here, disconnect all. Disconnect all. And I'm going to delete the sweep one. Just stick with the loft for now. Okay, so I can put, say, let's copy and paste this a few times. So I can copy, let's say 3 times. So that lofting piece of code just got copied 3 times. And here, let's say all these verticals are working fine. So I can set multiple geometries. Let's make sure everything's exploded. Explode it. Try again. Set multiple geometries. Great. Let's select the bottom and top and do those for the second one. Set multiple geometries. And let's preview. Turn the preview on. Okay, so you can see the ones on, and I just need the 2. Delete the other one. So the second one here is oriented the wrong direction. Let's say I want to swap it. It's easy. I can just swap the X and the Y. So I'm going to flip the wires here. Right? Or if this bothered me that it wasn't connected all the way, what I could do is move this off to the side. Make it a little bit closer. There are ways in Grasshopper we can like extend the line like half the width of the square, and that would, we can be very smart and automate everything. But I encourage you to kind of break it down into smaller components. It's going to make your life a little bit easier. Okay, so to make it like a truss, let's say that this is getting merged. Merge, merge, merge. Let's say I bake this thing. There's my Polysurface. Okay, and I'm still working at like 1-to-1 scale here, but if I zoom in here, we can see this is the size of how your model's actually going to be. Your model is actually going to be at 1/16 inch equals a foot, 9.5 inches by 15.5 inches. How did I get there? There is a thing called scale factors. And so kind of jumping ahead a little bit here, but CAD scale factors, there's a website called Arc Toolbox, kind of talks about this a little bit, talks about different drawing scales and different viewport scales. Basically, the scale factor, you can see, is sort of the same as the viewport scale, 1 over a number. For 1/16, it's 192, or 1 over 192. So in order to scale this from the real world size, where if I was to look, this is 65 feet tall, but I want to now shrink it to the size of my model, 1/16 inch equals a foot. I can type scale, click somewhere, and then it says, what's the scale factor? And so I can say 1 is divided by 192. It's very small. So that 65 feet is now 4 inches, which sort of makes sense. Like an inch is, there's 16/16ths in an inch. So 4 inches would be 4 times 16, 64. Okay. And then we'll talk more about this a little bit later, but in order to laser cut this, a simple kind of dumb way to do it is just type section. And so a section means that I'm cutting through this thing, say from the top to the bottom. Pull this line out. It gives me this guy there. I don't know why it added in some extra lines. Anyway, you can clean those up, maybe just using the trim command. I'm in the right view now. Use the trim command. To make it so that when I laser cut this thing, it won't all fall apart. Right? I've got like this thing. And then similarly, I could use maybe the fillet command with a radius equals 0 to connect those corners. Let's explode. Let's try fillet. Fillet, 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 fillet. This corner is a little funky. Yeah, fillet command used a lot. Extend command also works. Extend is kind of the opposite of trim. Or we can move control points. Okay, might be some cleanup in 2 dimensions that we have to do. Okay, so back to let's get a new rectangle again. Go. Okay, so how this can be used, let's say this piece of geometry, I want to put a big diagrid on it. So I can plug it into there. So that gives us this beautiful series of diamonds, or if it's just one, we're just going to get the half diamonds, the big V's. And you can see the output of this thing is a bunch of lines. There's a command in Grasshopper called join curves, which functions as the join command, and that will similarly turn this into a polyline, which means I can use the sweep. So if I copy and paste this one, let's turn it on. So I could sweep these join lines into a truss that goes across. And similarly, maybe for the rectangle that goes around the outside of it, maybe I just want a line at the top and bottom. Let's say it's a line at the top. I could run that through the Loft. I turn this all off, but there we go. So I can have a lofted line at the top and a swept line for the diagram. Sound good? So the way this works, to make it maybe a little more complicated, we could have, let's just pull this out a little bit. Let's rotate this rectangle by copying it. Rotate the rectangle by copying it. Rotate the rectangle by copying it. So I got four lines here. I'm going to delete these. You can play with them on your own time. Okay, so let's say one of these is the first diagram. Let's see if it works for all four. Let's see if I put 4 geometries. There we go. Look at that. And these are all, so they're not joining perfectly. They're kind of giving us four curves here, which means that the output is going to be, if I look at the panel right before the union, there's a lot more. Okay, so it's keeping it for every single little line. But the final output should be 1. Yeah. So it's like 1 truss that goes all the way around. So you can start to see how I can make more complicated relationships between these things just by linking them together and kind of making sure the lines touch and then doing the Boolean union at the end of it. Okay, so if I was to bake this, yes. There you go. There's like a truss thing. Okay, the other thing that Lunchbox has that is really helpful is, turn these on, panels. So we look at structure. Panels here, they're pretty similar. Diamond panels, hexagon panels, quad panels, staggered quads, and so on. Let's go back to my rectangle here. Let's say I input this geometry as my input, and let's go with the diamond panels. Let's turn that one on. And so we can see in red there, kind of a little bit harder to see. We can get diamonds, right? Like 5.5 diamonds. Even numbers will get you full diamonds. All right, and the output for these, if I look at them, is going to be a little bit different than the structure. The structure is like the lines that we get. This one gives us a surface. And so it's a bunch of surfaces in here. So it's, and if I want to look at, say, this list of surfaces, there's a component called list item. Look at some tutorials on data, trees, I'll tell you about this. but there's an index, and that's what this is, 0, 1, 2, 3, 4, the number here. So I can do a slider 0 through 4. And when I list items, it will show 0, 1, 2, 3, 4. You know, those are the diamonds. And the triangles are the little ones. Okay. Skip this. Okay, so under panels, those are how you make the panels. In the Generate tab, there's a couple things that are nice, specifically the panel frame. So this one, if I plug the diamond panels into there, and then there's a scale factor. This is a number between 0 and 1. So if I do 0 is less than 1.00 and plug that into my scale factor and click on it so I can see it, you see that there's a frame that's kind of appearing. And maybe let's do a piece of geometry as the output. That'll be the panel frame. And let's hide the panel frame component so I just see the frame. So you can see what that's doing. Pretty cool. Kind of touching at the edges there. So what I can do is, and this is still a bunch of different surfaces, join or brep join. This will, well, it doesn't do much. Yeah, it works better for the square ones. We'll talk about that in a second. If I do offset surface, if you don't install Pufferfish, you'll only see this one, offset surface. This is the default one in Rhino. This one is the one from Pufferfish Plugin. So again, Pufferfish is downloaded from Food for Rhino. Offset surface. And this is better because when it offsets it, it keeps it capped. It makes it solid, right? And so we can say by a distance, 0 through 5.0, maybe make it 1.6. All right, so you can see this is thickening this, and this is giving us a closed brep or a poly surface. One thing you may be starting to notice, and I won't go too deep into it in this tutorial, is when I'm looking at the panels, you can tell that there's maybe like 3 numbers here inside of parentheses, or the wires that come out of some of the components like change. This one's dashed, and this one is like double lined, and this one is single lined. What that refers to is data trees. It's worth a whole another lecture, but basically all you need to know when you're beginning is if sometimes you're not getting the result that you imagine, try right-clicking on the input or the output and choosing flatten. There's flatten, graft, simplify, reverse. Flatten and graft are what we use more than not. Flatten, you can see the output now got simplified. And so it reduced the amount of trees in the data tree. It basically makes the data easier to work with. For everything I'm showing you guys today, like we don't need to know much beyond, if it doesn't work, type flatten, okay? So let's see how we can link some of these together. Let's go back to this rectangle. Let's set it, turn these on. This is one that I left in the template for you. Let's set this one. And so this one, it's the staggered quad panels. And what that does is it makes panels that are staggered randomly. Kind of hard to see, U and V. And then there's another thing called S. This is random seed. So that just refers to if I move this number, it will readjust kind of what is happening here. Okay. So this thing is outputting. I can stick it into another panel. I could put this into triangle panels, for example, or triangular panels A or whatever. And what that does is it will make panels, diamond panels, inside of each panel of the first one. So it's like panels inside of panels. And you can see where I'm going here. We add a frame into it. We join those together, and then we offset. And what I've done is union them so that it turns into a single closed B-rip. And this works better for the ones with straight edges. The straight edges, it can actually join together. The diamonds, it's just touching at like a point, and it can't really join the surfaces together. Okay. And so again, if I was to change, say, the random seed number here, let's make it 2 rather than 18, it will change here. Or if I want there to be more divisions across, let's say 8 rather than 5. There we go. Okay, and then I can hit bake. Et voila. Big old guy here. Okay, those are really the important ones. I may jump ahead to the Bowerbird plugin a little bit, because that's useful for fabrication purposes. I can use it on here. Grasshopper Bowerbird. Okay, so this tool is specifically built for fabrication, Waffles, layer models, and a couple other ones. This kind of works like the slicer software that we used last year. I know some of you have kind of opened up Slicer yesterday and looking at it. You could use Slicer if you want. It just doesn't give you as much nuance and control as Bowerbird does. When you download this, there are some examples that come with it. Let's see if I can pull them up. There's like a number of different examples you can play with. And so basically what I'm showing you here is just from the examples. Copy and paste these into here. Okay. Bowerbird is a little bit more computationally intensive. I must have had something preloaded in here. If Grasshopper ever does this to you, or it's kind of hanging for a little bit, like just be patient, give it a few seconds. Okay. So Bowerbird, this is just one of the samples. This is the waffle sample. Maybe I'll look at the layer sample first. It's a little simpler. And let's start with something basic. Let's just do a sphere. So let's say there's like a sphere in Rhino. So the input, I can right click, I can input it, and it's gonna convert it to a mesh, and then it's gonna do the layer slicing on it. Everything to the right, all of this, this is orienting the layers onto the flat or the XY plane. It kind of flattens all the slices for laser cutting. Okay. So if I turn on the component here, we can see what it's doing. We have these little slices that go through of a certain thickness from a certain direction. Okay, so if I make this thickness bigger, there will be less points, right? Slicing it, it's like contouring basically as it goes up this thing. Let's look at the waffle example. Again, this is the Bowerbird example here. Let's plug in our sphere as the input. And what it's doing here is just moving the slices off to the side so I can see them. Lots of inputs. We can hover over these, but basically the X and Y, these are the number of divisions that you're gonna have across the surface in the X and Y direction. The thickness refers to the thickness of your material. So this would be the gap or the sort of the notch that's happening in there. So again, this is maybe something that you're either going to want to have to understand the scale difference as you're working, or maybe build your whole model at the one-to-one scale. Do your scale factor to shrink it down, and then when you're doing things for fabrication, you're doing it like at inches or 16th of an inch, 1/8 of an inch, rather than at feet at the real world scale. Okay, so what's super cool about this is it's taking this, and you really don't need to worry about all this, but it's making a bounding box of the geometry, and it's orienting all the slices. If we look at the slices here in the XY direction, the ones on top are the U's, the ones on the bottom are the V, but they're nice and flat here. So then I can fabricate. This stuff off to the side is the labels. So it's going to be adding in numbers and letters, that way, and you can have these like engraved onto the geometry or onto the boards, right? So it doesn't need to be cut all the way through. You can have it engraved. So after you get your pieces back from the laser cutter, like you know which one's which, right? They'll be in order. Okay. These are nice and kind of pre-built for you. Let's go back to my example. Actually, I made a big one down here at the bottom. And I'll spend some time kind of walking through this one. Okay. So this is at the bottom of your sample definition. There's a few other things that I'm not really going to cover right now in the interest of keeping this sort of short. This one, Pufferfish, does a voxel shell. That's what this guy does. Basically, this might be useful for smaller sort of square shell structures, but I'm going to show you a way it's a little bit easier. This plugin is a tool called Mesh Pipe. This is, I believe, a plugin called Mesh Tools. I think you need to download this one. It might come with the newer Rhino. This is like the pipe command, which draws a circle with a radius around a curve, right? But in this case, since this is a mesh, we can reduce the number of segments. So rather than it being like 10 segments, which looks like a circle, we can make it to 4 segments, which looks more like a square, right? This is a little bit messy, a little bit harder to control, especially the orientation of that square. Usually it comes out looking like a diamond rather than a square, but it's a nice component for quickly turning curves into 3D things. This one, I'm just talking about contouring a surface. Don't need to cover that too much. These two I've covered before for you guys. These are ways to generate stairs. So again, you can have decorative stairs inside of your project. This one is a stair from a flat curve. And let me just show this real quick again. So I have a curve here. Copy and paste these. I can input my flat curve at the beginning, and then these are all the outputs, these previews, so I can turn them on. And this is very small. Let's scale it down a little bit. As you can see, it's giving us a 3D stair based upon all these parameters, all these inputs. So like total height, make it taller, step height, the width, the overall stair width. Let's make this like 3 feet. It's gonna be a lot narrower. Handrails and all that, okay? The other one, it comes from a point, and the start point will give us a simple spiral. If I turn these on, this spiral stair situation. There's other ways. These are just two. Internet's full of different solutions of how to make stairs in Grasshopper, but these are two I thought you might be interested in. Obviously, for fabricating, like for your physical model, I don't think it's that you should be cutting out individual stairs and spending time gluing stairs together. That would qualify as a waste of time. I would just maybe make a regular spiral and like basically a circle, and then cut the middle of it and pull one up and down and glue multiples of those together to kind of make a stair. But for your sections, maybe this is useful for you to have. Okay, I'm gonna skip down to this bottom one. So this kind of covers a few things, but grid of boxes cut out by the site and culled with random points and sliced for laser cutting with Bowerbird. So let's look at our site again. We've got this surface. So I just want to get the outline of it. So I'm going to go dupe border. So that will give me just the border. And I'm going to put that into the 2D outline here at the beginning. Set one geometry. See how this works. And you might find even just the first part of this definition helpful. Basically, it makes a stack of boxes, a bunch of pixels put on top of each other. Another way that you'll hear that called is like voxels. But this is doing it without getting into voxels. Voxels is like a pixel, but it's in 3D. That's a voxel. Minecraft is all voxels. Oop, looks like it worked. Okay. I'm going to turn off some of the stuff at the end of the stream here. It's going a bit slow, specifically the Bowerbird stuff. Don't need that right now. And I'm going to turn off the Boolean union. There's a way, I think I'll profiler, we can see like how long each component's taking. But okay, let's go back to the beginning. So this is making an extrusion here. That's all that top part is. This part is deconstructing this box to make a rectangle, which is a certain size. I have it 18 by 18, but we can make it like 15 by 15. I'm just gonna leave it 18 by 18. It's making a box of that rectangle that is also 18 feet high. And then I'm arraying that box a bunch of times, like a whole lot of times. And it's getting arrayed X, Y, and Z number of times by the cell, which is the size, which is, I just made it the same box. Okay, that's all that's happening here. This little bit is I'm testing to see if those boxes are inside of the site outline. And then if they're not, they get removed. Okay, so this component is called point in breps, or point inside of the polysurface, like point inside of that this extrusion. And so I was looking to see, like, all of these boxes, they have a volume, which gives us the centroid. So they have points, like all these points here. And all this component is doing is testing to see whether these points are inside of this red volume. This guy is equality, so it's testing to see if it's equal. If it is equal, then it gets culled. It gets removed. And so we're left with, let's hide everything. We're left with just the boxes that are inside of the site. They're overlapping a little bit. I might need to, offset that a little bit. We could, I don't want to freeze Grasshopper here, but we could offset that line inside to make these not overlap. Many of you are asking about the site, like, get it pretty close. Don't worry if you're overlapping the site a little bit, not the end of the world. Okay. What this little part, it's doing is it's populating on our box some random points. That's what these 5 points are. It's populating. We have a seed here, random seed. So 5 points randomly around here. Let's do less. Let's do 3 points. And it's looking, this is like more than you guys need to know, but it's looking for the closest point out of that collection of points. So all these points, it's finding the closest point. If it's larger than a certain distance away from it, and then it's culling. So it's removing geometry if it's close to these points. So you can see the green point here, how there's no boxes around it. So similarly, rather than culling based on random points, like I could draw a point. I could say, here's a point. Put that into Grasshopper. Set 1 point. And I'm going to put that into here, into the closest point, rather than this random 3 points. So think a little bit, and it didn't do anything, but let's move the point closer to our site. And we can see now it's like removed those lines. And then if I make this distance bigger, let's make it 60. It will remove more boxes. Or 80, right? Kind of like carved away those boxes. So giving you guys a little preview of how we can use Grasshopper and to get to different degrees of complexity a little bit. Anyway, let's hide all that. And what I'm doing here, it's deconstructing that brep. And so this component gives me faces, edges, and vertices, so surfaces, lines, and points. And then I'm taking the lines and I'm removing the duplicates. Because each of these boxes, they share a face. So there's going to be like a duplicate line at every single box. So I'm just removing those duplicates. And this gives me just lines. Just all these lines. And then if you see where I'm going here, this is the same as up above, the Loft guy, right? So I'm taking each of these lines and I'm lofting them, and then I'm gonna Boolean union them all together. So this will take a second to run, but it's going to, it might take a couple seconds for it to run. It's gonna convert all these lines into one closed polysurface, kind of 3D thickened thing. Let that go here. Bowerbird, you can also download things. A lot of these people who develop these plugins, they're coders, they're great, and so they use GitHub. And so you can download new versions or the examples from GitHub. Okay, give this a little second here. Okay. So one closed brep. This guy. A 3D moment frame of a certain size, right? So that might be kind of helpful. Okay, so what's happening down here? What it's doing is I'm using Bowerbird to slice this thing. I'm gonna turn these on, let it warm up a little bit. So what Bowerbird does, it will slice whatever geometry you plug into it based upon either the waffle or layer settings. So layer does it just in one direction, like think about like a topography model. It's just sliced in the Z direction, and it kind of stacks just vertically. The waffle grid one, maybe we'll look at it here. The waffle grid one has two inputs, divisions in X, division in Y. And so we could divide up a surface based on these two numbers, and that's it. But what if we have something that's like more specific? Like this one, I want to slice it at every intersection along there. In that case, I want to use the sections, this Bowerbird sections plugin. Okay. So maybe before I show this one, I'll just show maybe on this guy, this one that I made earlier. So let's type in geometry, set one geometry, sections, BB section, that's it. Okay, so it's looking for a mesh. This geometry that I put into it, I believe it's not a mesh. It is going to be a brep. So I can convert it to a mesh if I just type mesh brep here. So there's my brep. Here's the mesh. Okay, and then this one, it's just a flat sheet, and so it probably makes more sense if I want to laser cut this thing to like cut it right down the middle. And so to make this simple, like I would just stick a point, and say there's a point in the middle. I have a piece of geometry in Grasshopper. Let's set one geometry. And the point I want to slice in a certain plane. So again, I'm looking at the Cartesian. I see YZ is sort of the orientation of this thing. So I could type YZ plane. And stick that into the plane. Okay, it still wants the thickness of it. I'm not working with real world, so let's just say 0.2. Or I'm still at real world scale. I probably would want to scale this down using my scale factor. But then you see we have section curves. So I'm just going to move these over so we can see it. In the X direction, 50 feet. Just want to kind of show you what the section curve looks like. All right, section curve, pretty cool. So I could then bake this and then throw it to the laser cutter, and there we go. Got something cool. This thing, or here, let's do the sphere. So this one, I want to set one geometry. I'm going to do a few points. So let's say there's a point here, there's a point here, there's a point here. Let's just do the 3, okay? This slider we don't need to worry about. Let's do 4. Okay, so I'm going to copy my inputs. There's 4. I'm going to stick, each point is going to be here. Okay, and then for the sections, I'm going to want to merge here. I'm just going to do a couple different orientations. So I got the YZ, and I'm going to do XZ, the other direction. These 2 points, the top ones, are going to be XZ. So I'm holding shift and plugging them into there. And then these 2 bottom points are going to be YZ. Both of these planes, XZ and the YZ, are going to get merged. And again, I know this is the most confusing part of Grasshopper, this like data stuff. It does take a little while to get your brain around. So I'm going to merge in, so 2 different planes, 2 different orientations into my section. If I look at this, I'll move it over a little bit. This one didn't get set. So multiple geometry. Okay, so we can see these are the moved sections, the sections that get cut through there. It's doing some in the X and some in the Y. So if I was to move, say, the point, it will move where the slice is happening. And then, there's ways to get more intelligent about the planes that you're cutting. I showed you guys the perp frames one. Let's just see how that looks. Like here's a curve. Let's do the geometry, and it's got the perp frames. You can see it's a bunch of frames and they're kind of like in this arc around the sphere. Let's plug those into the planes and see what happens. You can see the slices that we're getting around our sphere are, if I look at the top view, this plane here on the curve, if I draw a line all the way through, you can see it kind of lines up with these slices, these slice lines. So I'm being a little fast and loose here, and maybe be a little more careful with, or maybe make an actual circle that would be the same radius as this thing. But you get the idea, kind of where I'm going. Okay. So go back to our moment frame, all these things. So I want to slice this sort of intelligently. I know that to make the box array, so this array of boxes that I had here, it's doing it by a certain dimension, this box size, 18. So again, if I want 12-foot boxes, I would change this number to 12. 10-foot boxes, I'd change it to 10. What I've set up for you guys down here is an array. So it is arraying, it's just points. I look at over here. So I've got points in the X, Y, and Z direction according to what we got here. So I'm using, just like I just showed you in a previous example, all of the, say, X points are feeding into the YZ plane. Again, so I'm looking at the Cartesian guys here. I want these to, if I turn this on, if I zoom in, we can see these little planes are like pointing towards my geometry here. And vice versa, the XZ plane are pointing the other way. Okay, and so I'm feeding those, they're getting merged together and going into my section. So again, if I hide everything and just look at the section, and zoom in on this thing, we can see it's just a line, it's no longer thick, and there's like a little notch. We even include the notches there. So for the thickness, let's make these notches bigger so I can see it. 0.6. This little notch will get a little bit bigger. A lot bit bigger. There we go. Okay, and then this last bit here, again, you don't need to worry about what it's doing. It is orienting all this stuff onto the ground. And this one doesn't have labels added to it, but we could look at one of the examples. Maybe I'll update this so it has the label maker on it. But generally it's kind of like left to right, kind of easy to figure out. If I zoom in here, you can see they have that notch. So this way you can make a nice waffle grid, have this whole thing. I mean, if it's cut out of HDF, you need to, two things to worry about is like the thickness. So the rectangular cross section of the members, like I wouldn't go below 1 for these 1/16 models. So 1 for a 1/16 model is 1/16. 1 foot equals 1/16, which is pretty thin, especially when you're dealing with the laser cutter and all that. So if anything, like oversize your members a little bit. That way, when you laser cut it, it doesn't like lace and doesn't totally fall apart. Okay. That's the bulk of what I kind of wanted to show you guys. Just know that, you know, automating everything like this last example I showed you is going to require like a little bit of thought. And so what I would encourage you to do is like build up your chunks that you have here and think about either using the Bowerbird section component by slicing it specific ways, or in Rhino, like just using the section command. Or intersect is another command. And so we could do something like, say, the sphere is in red and I make purple layer live and I do a command called CutPlane. And what that does, if I go in like the top view, I can draw some lines that go through my object in different ways, and it makes a cut plane. Okay, so then I could do intersect command to intersect all this stuff, and then I have these lines. Again, I would have to rotate them in such a way, you know, I just did these in random orientations, but rotate them in such a way that they're flat in the top view for me to be able to laser cut them. Similarly, in Grasshopper, we could do this geometry. Let's say one of these is the sphere. A couple of these are the, or let's say all of these cut planes go into one. In the intersect command, or in the intersect tab, there's a bunch here. B reps with lines, B reps with planes, contouring, talked about that a little bit. Physical, if I want to do like a B rep with a B rep, so I want to intersect the sphere with all of the cut planes. Hide everything. Again, in Rhino, hide, show, isolate. These are your friends to be able to not look at everything that's on the screen here. Frozen here. So anyway, this intersect command will just show us the curves, just like the, or this brep to brep command shows us the curves like the intersect command in Rhino. A little frozen here. But that's the bulk of what I want to show you guys. There is obviously lots and lots of stuff that we can accomplish through here. The goal is to finish, so perfection when you're modeling should not be the goal. Just remember, design into things that you're going to see on camera. Don't worry about things that are off camera. Don't worry about things we can't see. So for example, just to kind of go over this, this thing that I have here, if I was to look at the, say, left side, and I was to type clipping plane, and I go into the top view and I move that clipping plane back and forth, you can see on the left side how it sort of updates. It's a little hard to see because it's flat. So let's go into my side view. Let's change the projection from parallel to perspective. And let's change the lens length from 50 to 21. Let's select the geometry. Let's type ZS to zoom. And let's move these back and forth and we can see the result. So I'm kind of looking at from the left side here in that way. And let's change the view to pen just like for the preview. See if it works. All right, so I got a pretty good sense of how this thing looks in a section perspective. I could save this as a named view, or I could set up a sheet, right? I could set up a layout that is 36 by 72 tall. Double click into it. Let's reset this up. Let's say this one is from the left. Let's say the projection is perspective. 2-point perspective even. Smaller lens length. And then clipping plane. I'm gonna have 2 clipping planes here. This might require, if you click, hold, and drag, you can pull your viewport out. So we can look at this thing. And again, I've told you guys the scale for these should be 1/8 inch equals a foot. Since it's perspective, it's a little bit harder to scale. I just wanted to fill a 6-foot tall page. Get it close to 1/8 inch equals a foot. And we're going to do Make 2D and bring it to Illustrator the same way we did before. Right now I'm just doing the preview of the pen mode. But we can see if we move the, let's make this bigger. If I move the clipping plane back and forth, it kind of shows me the preview of what's getting cut. Right, when I come forward, it's maybe cutting off too much. Zoom out a little bit. Right, so the clipping plane is just a preview. I'm not actually removing information from this side, right? And it's got some benefits where I can see the poche, and the poche is like the color of the layer, like whatever material I have here, that's the color of the poche, the cut through these things. Or the other way to do it is to use a cut plane. So I would literally take all this, I would do cut plane. I can do it along the clipping plane, that's fine. Where's the cut plane? There it is. So big old plane that goes through there. And then you could use the split command or trim command. I want to split all of this with the cut plane. It's going to take a little bit, but then what I would do is delete everything that's on the front side of it. So it's a little bit more drastic than just using a clipping plane, but will yield better results when you're doing the Make 2D. Let's see how long this takes. There we go. So then we can select the front side of it. Make sure we ungroup everything. Ungroup. There we go. And I can delete that. I can delete the front. And now I've sliced through this thing. Right, and then I can run Make2D on it. Cool. So either way, you can do clipping plane or the cut plane in this split. You will find out there's benefits and differences to both of them. But in the interest of time, I'm going to cut this tutorial a little bit short. Hopefully this is a good overview. Again, I know this stuff is hairy. If you show drawings of what you want to accomplish, meaning like a sketch of what you want to accomplish, or tracing over like a Rhino model of what you have, we can help you troubleshoot, okay? Come to office hours, send me Grasshopper or Rhino models via email, and we'll do our best to help you guys make these models really sing.